Hi everyone. In this video, I'm going to talk about chi-square test, the goodness of fit test. And I want to talk about writing it up. I'm going to talk about it conceptually. I'm going to talk about doing it on JMP and also on an online calculator. So let's just talk about what is a chi-square goodness of fit test. Well, this is when you want to see if proportions you have are what you would expect to see. All right, so you might want to see like disproportionality. Like I'm a researcher in gifted education, and so one of the big issues in our field is that we don't have a lot of representation of students, of minority students in gifted education. So like we'll do a chi-square goodness of fit to see if African American students, if the number in gifted programs is what we would expect to see based on the proportion of kids in the school. So if you only have, if 20% of your school is African American, but you only have 4 students in the gifted education program, is that what you would expect to see? And probably not. And so the goodness of fit is going to be able to tell you that. So here I'm going to work again with a CARS data set. And I'm just going to do something like, hey, we'll just look at drive, is this what we would expect to see? Are these the expected proportions of front wheel drive, rear wheel drive, and both? So I do analyze, distribution, and I'm going to put not airbags, I'm sorry. I'm just looking at drive, that's all I'm looking at. Okay, so put it in drive. So what I will do is I'll go and I'm going to test probabilities. Here's the hard part about a goodness of fit test for chi-square. You have to think, well, what do I expect to see? What is it I'm actually wanting to test for? So what you would have to do is read up on the literature and understand, is this, what is the, in Tennessee, what is the proportion of front wheel drive, both wheel drive, and rear wheel drive, and find that in the literature. And so that's what I would actually enter in here. So if like I looked up in the literature that 20% of cars are both, and that 30% of cars are front wheel, and what does that leave? 50% are rear wheel, then those are the proportions that I would enter, okay? Sorry, 0.50. But sometimes I might want to just see if there's more of one than another. And so if that was the case, then I would split this proportion up evenly. And so I would say, let's just test against the probabilities of 33%, 33%, and I've got to make this add up to 1 and then 34%. That's the only reason why I put 34% instead of 33%, so that all of this can add up to 1. And so when I do this, I'm testing to see if there's more of a proportion of front wheel drive than what I would expect if everything was even. All right, so you really have to kind of wrap your mind around what is it you actually want to test. Do you want to test it against expected proportions, which you find in the literature, or do you want to see if proportions are considerably more than one another, and you would divide that up evenly? So if you just had 2 levels, you would have 50% and 50%. If you had 4 levels, you would have 25% on each of those. It really just kind of depends on what you are looking at. All right, so I hit done, and then it tells you, yes, that these proportions are different than these proportions, that indeed it looks like, especially front wheel drive, that's a lot more, that's represented a lot more in this sample, where it's not necessarily evenly proportional. There's more front wheel drive. So this test right here doesn't exactly tell you where, And so what I've encouraged teams to do when they're doing this, they just would go back, they would just actually report the descriptive statistics and say 72% were front wheel drive. Wouldn't that be an interesting dissertation? And just show how these differ. But there's now no post hoc to this, is really kind of what I'm saying. So that's how you do it on here. But I need to tell you something. Sometimes you may not have the actual data set in JMP. Like I've been working with a team and they were looking at number of alternatively certified teachers and number of traditional certified teachers, but they didn't have it in their data set. They just knew the numbers. And so they were dealing with thousands and thousands of teachers, and it would have been like silly to just put in, you know, alternatively certified over and over again. And so instead of doing that, I showed them how to use an online calculator to do the same thing. And so what you would do, let me make sure I'm sharing the right thing. Okay, so what you would do, you go to this calculator called Vassar Stats, okay, Vassar Stats. And what you do is you put in the numbers that you know. So you have 16, we had 16, we had 43, and we had 34. And what is the expected proportion? 17%, no. 33%, 33%, and 34%, just to see if, hey, is one of these more than the others, like significantly more than the others. And so you hit calculate, and this chi-square is the same that I had found on the JMP program. Yeah, wait a minute, which one? No, it's not. Now that is interesting, but it was just a minute ago before I did this video. Let me pause this for just a minute. Okay, figured out what I did. I entered the wrong numbers. All right, so if I go back to JMP and look at how many cars are in each group, it's 16, and it's 43, and it's 34, and the expected proportions, because I'm using, I want to see if one is represented more than the other groups, and it's statistically significantly more than the other groups. Wait a minute, I keep putting these wrong numbers in. Okay, which numbers am I looking at? It's actually 10, 67, and 16. I'm sorry you're having to watch this, but you know what? There's going to be so many mistakes when you do statistics, like you end up having to do them over and over again with missing data and all kinds of things. All right, 64.62, that is exactly what I got on JMP, but sometimes you may not have a whole data set to work with. You will just know the frequencies, and so this is how you do it. All right, let's talk about, again, conceptually, what you are doing here. So I'm going to just walk us through an example of what your research questions would look like. Let's just imagine you want to know if the number of teachers who have national board certification, like maybe in Tennessee, is it really different than the national percentage? Doesn't that kind of sound like a one sample t-test, except we're dealing with percentages and proportions instead of means. So my nominal variable are teachers who have national board certification and those who do not. That's how I've coded my data. So here's my question. Is the percentage of teachers who hold national board certification in Tennessee different than the national percentage? And so really what the chi-square test is doing is helping me see if the observed frequencies are different than the expected frequencies. All right, so my null hypothesis is the observed percentages of national board certified teachers do not differ from the expected national average. And so my assumptions are that I'm using random and independent data. I need at least 20 observations, and otherwise I don't have any assumptions. Because I'm dealing with nominal data. I like to think about a chart that I'm working with. So for example, there's 13 teachers in Tennessee who have, I'm just dealing with 100 here. So you really would never have just 87, but this is the way I'm doing it with this example. Actually, you could, okay, let's just do this. Let's just do this. I don't want to be confusing. So let's just say in reality that in the national average is that 33% of teachers have national board certification, but in Tennessee there's only 13%. And you want to see if that is different. Now, degrees of freedom for Chi-Square, here's how it works. You look at the number of categories you have. So we have national certified teachers. We have national board certified teachers. That's one category, and then the other category is Tennessee versus the nation. So we have two categories. So our degrees of freedom is N-1. Let's say I don't have a data set for this, so instead I'm going to use this calculator here, and so I put in that these are the numbers of teachers that I have. These are the expected proportions that I have found from the literature that really 33% of teachers should have it, but in my sample there was only 13. And so what this will show me is, hey, and actually I didn't have to fill in this middle one. It did it automatically, but you could do the math as you're just figuring out, you're just doing 7th grade math and figuring out what would be the expected frequency based on the expected proportion out of 100 people. That's why I chose 100 people to keep this easy. All right, so it was statistically significant. Yes, there is a difference. So Chi-Square Goodness of Fit revealed the proportion of national board certified teachers is statistically different from the national average. And so this is how I write this, and then this is a phi coefficient, and that is the effect size. So how do you do effect sizes? So how do we do effect sizes? I'll get to that in a minute. So here on this document, I have, again, exactly step by step what I did to do this in JMP. And I have different versions of null hypotheses. I encourage you to look at this. Other ways to write out null hypotheses. So for this one group that I've been working with, the observed proportion of alternatively certified teachers and traditional certified teachers is equal to the expected proportions. All right, that's a different way of writing it based on what they were doing, because they think that theirs are different. That would be their alternative hypothesis. And then if you're looking at, hey, is one more than another, then you would do it like this. There is no statistically significant difference between the rates of alternatively certified teachers leaving and traditional certified teachers leaving. And so then I put in 50% as the expected proportional rates. So you really have to think as a researcher, what is it you're actually doing and finding? Okay, so for effect sizes, I have that written on this document. You can Google actually Kramer's V, how to do it. There's probably an online calculator to figure that out. But Kramer's V is probably the easiest thing to do, and that is when you put the chi-square, and then you have, this tells you right here what to enter, all right? But that you would report either the phi coefficient or the Kramer's V, depending on if you have a 2x2 contingency table, or if you have larger than just 2x2. If you had 3 groups or more, then you use Kramer's V. All right, that's about it. I've got to go to a defense, and I will talk to you later. Bye.